Today I am going to explain how Coulomb's law relates to effective nuclear charge, what we call Zeff, and nuclear pool NP. So just imagine, let's say this is one positive charge, this is another positive charge, and this is one negative charge, this is another negative charge. So the relationship between these charges are the same, right? So positive will interact, this is repulsive forces, and negative also repulse each other, right? So the relationship will be FR. R means repulsion, right? So repulsive forces will work between the same charges, right? So now look at the Coulomb's law, right? Coulomb's law. And Coulomb's law, we know E is proportional to Q1, Q2 by D square, right? The D square is the distance between the charges, the distance. So in case of same charge, Q1, Q2 is plus. The product of Q1, Q2 is plus because Q1 and Q2, they are either plus or minus, right? So because of this, they will repulse each other. The relationship is repulsion, right? So they will repulse each other. So if Q1 repulse Q2 or Q2 repulse Q1, what is going to be happening? The distance between Q1 and Q2 is going to be larger, right? So the D is going to be bigger. So if D gets bigger, what happens? So the D is here. D is inversely proportional to E, energy, right? So energy E will go down. The E will go down. So now imagine, so this is one positive charge, this is another positive charge, right? This is one atom, this is another atom. So, and over there you have electrons. So when you push them from opposite sides to bring them together, what happens? The electrons that are located in this region, right? So the electrons, they will repulse, and because of this repulsion, the electron will redistribute. They will go away from each other, right? They will go away from each other. And because of this, what will happen? So now we see the electrons are distributed here in this region. So the nucleus of this atom and nucleus of this atom, they will expose to each other, and they will also again push each other, right? They will repulse each other. So this is something like similar to shielding, right? Similar to shielding. And we have seen, if you have more shielding, right? If you have more shielding, Zeff, effective nuclear charge, right? Zeff, which is Z, number of protons minus core shell electrons, right? Core electrons. So in shielding, the core shell electrons increase, right? So from the proton, if the core shell electrons increase, what happened? Your Zeff will go down, right? Effective nuclear charge, Zeff will go down. And when Zeff go down, you will have less nuclear pool. Nuclear pool will also go down, right? So now look at here. Here you have one positive charge, another negative charge, or one negative charge, another positive charge, right? So they will attract each other. Positive, negative, minus, negative, plus, positive, minus. That means the attractive forces will work between them, right? So they have they will attract each other, attractive forces. So now go back to Coulomb's law. E is proportional to Q1, Q2 divided by D square, right? So when Q1, Q2 here is negative because one is positive, another is negative, or one is negative, another is positive, right? So their product is minus. This minus means the attractive forces are working between them, right? So now, so this is Q1, this is Q2. So Q2 will attract Q1 and Q1 will attract Q2. So because of this, what will happen? The distance between these charges, right? Between the charges will go down. This is D will go down. So if the value of D decrease, that means E will increase, right? E will increase because they have inverse relationship. E will increase. So what does it mean? So this is one atom, this is another atom. So they are pulling towards each other. So because of this, you are going to have orbital overlap, right? You are going to have orbital overlapping, and the electrons that are located here, so this electron is now, you see, they are sandwiched, right? They are sandwiched between the nuclei, two nuclei, right? So electrons sandwiched between two nuclei, and when electrons sandwich, they will feel more attraction from both nucleus, right? They will feel more attraction from both nuclei. So because of this, you see, your penetration will go up. This is a sort of penetration, right? So if you have more penetration, what's going to be happening? So the number of core shell electron, the value of core shell electron will go down, right? So when value of core shell electron go down, we know Z minus core shell electron is Zeff, effective nuclear charge. So Zeff is, the value of Zeff will go up, right? So Zeff will increase. When Zeff increase, what happens? We also get increased nuclear pool, right? So nuclear pool will increase. So this is the relationship between Coulomb's law, effective nuclear charge, and nuclear pool. I hope you enjoyed it. Thank you so much for watching my video.